All right. Week 16, lesson 26. It's talking about scale factors. This is getting into geometry. This is the first lesson in Unit 6. So today we're going to be able to find a scale factor, be able to use that scale factor to find a missing side length, and also be able to create scale drawings using a scale factor and known side lengths. So this is all the stuff 21.1.2.3, so all of lesson 26. So first thing is, well, what is a scale drawing? Scale drawings are always proportional. Okay, remember that a proportion is two fractions that are equal to each other. So if I had a square, okay, so say I had a square, or technically this is a rectangle. This side length is 1, this side length is 2, this is 2, and this is 2. And I have a bigger one over here where now my top is 2 because my top over here was 1, right? So these two are going to be the same sides, which means that these two on the bottom are going to be the same sides. So you'll see more images like this in a little bit when we kind of start working through them. So each corresponding side is an enlargement, meaning it gets bigger, or a reduction, meaning it gets smaller from the original. So this first rectangle here that I drew, this would be the original, right? 1, 1, 2, 2. And then this one over here, the new one I drew, is an enlargement because it's getting bigger. So since 1 is up top here, this is the shorter side, that means that this 2 up here is still the shorter side, it's just a little bit bigger. So here's an example. Okay, it says that EFG, so this rectangle over here, is a scale drawing. Another thing to note is that scale drawings are always the new image. Okay, scale drawings always come second. The scale drawing is always second. So that means that the first rectangle here, notice how this top side is 3, which is smaller than 6, right? So when I look at my smaller rectangle here, the top side is still smaller than the length 4. So over here I would have like 3 over 6, which would be equal to 2 over 4. So 3 over 6, which would be equal to 2 over 4. Okay, so scale drawings are actually used all the time, everywhere, whether or not you really realize it. I don't know if any of you guys are into figurines or figures or even just like dolls or toys, sometimes even like toy cars. Those are usually scale drawings. So this figure here of Maleficent from Sleeping Beauty, it's only 8.57 inches tall. However, in real life, I'm using air quotes, like if Maleficent were to actually exist in real life, she would actually be 70 inches tall. So again, this is my original, right, much bigger. So this would be a reduction because I'm going from a bit large to small. A small little 8.5-inch figurine. Here's another example. I don't know if any of you guys have seen these, but there are some people that take a Bob Ross picture and paint a mural of it on their wall in their bedroom. So this is an example of an enlargement, right? Because this canvas that Bob uses is 16 by 20 inches. But when I take this canvas and I stretch it over this entire wall that's 10 feet by 15 feet, it's getting a lot bigger, so it's an enlargement. This video is pretty cool. I would watch it on YouTube. I think stuff like this is fun. Alright, so again, enlargements versus reductions. So an enlargement, so notice how I start small, right? This triangle over here is relatively small, and then I'm going to this big triangle. So from small to large is enlargement. Reductions is going from something bigger to something smaller. All right. First letter of the quiz code this week is lowercase s as in simple. Lowercase s as in simple. All right, let's get into how to actually find scale factors. So I kind of broke it down into steps. At the end of this slide, I have a fraction that I would suggest writing down somewhere, taking a picture of, or putting it somewhere maybe on a post-it note where you can see it, because it'll help you a ton when you're doing this stuff. The first thing you want to do is pick one side from the original image, which is typically on the left. So just one side. It doesn't matter what side it is, just one. Then you want to find that same exact side on the new image. Okay, remember the new image is usually going to be on the right-hand side. So you pick one side on the original image and you're going to find that same exact side on the new image. Then you're going to create a ratio by putting the new side length over the original side length. And you must always simplify. Okay, always simplify. So let me take that example that I drew at the beginning really quick to kind of put a picture to what these words are over here. So first, step one, pick a side on the original image on the left. Let's pick one, the top side over here. I'm picking this side. Let me grab a different color. I'm picking this top side right here, so this number one. That's my side I'm choosing. And what I want to do is pick that same exact side, but on the new image. So if I look at this rectangle, I want to pick this top side because it's the same exact side on my new image, which has a 2. Then I'm going to follow my ratio, put the new side length on top and the original side length on bottom. So here I have 2 over 1, which means my scale factor is 2. Okay, so my scale factor here, my SF, is going to be 2. And we'll do tons of examples with this, okay? So that's kind of what we're doing here. So let's get into it. Remember that the original image is always on the left, the new image is on the right. Okay, so I have this triangle ABC and triangle DEF. I'm going to pick, well, first we got to pick a side, remember? So it's new image over the original image. Okay, so let's look here. Let's pick this side 9, this side right here. Okay, so this means when I look at my scale factored, my new one, I need to pick that same exact side, and that gives me a 3. So this 9 is my original, and this 3 is on my new image. Okay, so 3 is going to go up top, 9 is going to go on bottom. Now, you have to always simplify when you are finding scale factors. Okay, scale factors always need to be in its simplest form. So remember that if you struggle with simplifying fractions, that's okay. You can pull open that Desmos calculator that I use all the time, and I'm pulling it up right now so I can show you. And if you just type in your fraction, it'll help you simplify it. So my fraction's 3 over 9, right? And if I hit this over here, it will simplify it for me. So to that 1 over 3. So if you're struggling with fractions, pull open this Desmos calculator and use that. So that means that my scale factor here is 1/3. Second letter of the quiz code this week is N as in neighbor. N as in neighbor. So you should have lowercase s as in simple, N as in neighbor. All right, here's another one. So yes, there's decimals. Don't freak out. Remember, you can use a calculator. Let's try it. Let's do this bottom side. Bottom side over here. My bottom side is 5. Remember, your left is always your original. And let's look at the bottom side over here. This is my new image. This is my scale drawing. So I'm going to put my new. I really can't spell today, can I? So I'm going to put the new number, my new image, over my original. So that means I have 7.5 over 5. Now let's see if this simplifies to anything. I have 7.5 all over 5. And it simplifies to 3 over 2. So that's going to be my scale factor, 3 over 2. So this is 3 over 2. My scale factor is 3 over 2. All right, going into how to find a missing side length. Okay, so we're going to do this the same way. Well, actually, hold on. Did I put this? Oh, okay. Okay, I see what I did here. So I'm going to go through the steps on how you find the missing side length. It's not that much different. There's usually just there's one extra step at the end that we have to do. So first thing we're going to do is find the scale factor using other known sides, which means that since I don't know what my x is down here at the bottom, when I use this to find my scale factor, I don't want to pick the 6 as my side because I don't know what x is. So you want to pick any other side where you have both numbers. So if I pick this side here, and I look up here on my image, both of those have a number next to it, so that's a great place to start because I have my 2 numbers for my scale factor. From there, you want to identify the corresponding side lengths, which we just did. Then, when you have your scale factor, you're going to take that scale factor and multiply it by your known side length, which is the 6, because I'm trying to get to this x over here. So before we go through fully solve this, third letter of the quiz code is going to be O as in octopus. O as in octopus, or octagon. Alright, so let's go through and solve this. So remember, the first thing we want to do is find our scale factor. I'm going to put SF. Okay. Let's use this side 5 and this corresponding side 2. Remember, it is new over original. So my new is 2.5 over my original, which is 5. If you type this into a calculator, it will reduce to 1/2. Okay, so I have that 1/2. After I know what my scale factor is, the second thing is I want to take my scale factor, this 1/2, and multiply it by the known side. So when I look at this image, I want to know what x is, which is the very bottom. So when I look at my original image here, I need to use this number 6. Okay, since I don't know what x is and that's the bottom side, I need to look at my original image, the other picture, go to the bottom and see what number is there, which is 6. So I'm going to multiply this by 6. If you do 1/2 times 6, that will give you 3, which means that here x is 3. Now, if you noticed, there are sometimes when you have questions like this, there's easier ways to kind of look at it. If I look at this 5, all of these sides are 5, right? Here's a 5, 5, 5, 5. And if I look at this image here, this is 2.5, 2.5, 2.5, 2.5. So you could look at these and go, well, all of this, if I take all these 5s and divide them all by 2, I get 2.5 for all of them, which means if I take 6 and divide it by 2, I'll get 3. So there are patterns that you could see here. I'm going to go back to one of the other examples. This one's kind of harder. For this one here, all of my side lengths are 9, right? So if I take all these 9s and divide them by 3, I will get 3. All right, another one. What's the value of x? So here I have 1, 2, 3 sides. I don't know what this bottom side is. Again, I don't know what the bottom is, which means I don't want to use this 3 because I need that to find this value. So let's use this long side here with 5. I'm going to use this long side here with 15. So when I find my scale factor, remember it's new over original. Your new image is always on the right. Your original is always going to be on the left. So that means I'm going to put 15 over 5, which is 3. So my scale factor here is 3. The next thing I want to do is double check that I'm plugging it into the number 3. So you want to take your scale factor and multiply it by your known side. So that would be 3 times this 3 over here, which will give you 9. So that means that that x right there is 9. And again, if I look at this 4, if I look at 4 here, right, 4 times 3 is going to give me 12. If I look at 5, 5 times 3 is going to give me 15. If I look at 3, 3 times 3 is going to give me 9. But in case you have a question with maybe a little bit trickier numbers, this is a good way to have as a backup. It's a good way of knowing how to do it. Fourth letter of the quiz code is going to be W as in winter. W as in winter. All right, how to pick the correct scale drawing. This is a little bit trickier, but it's not that bad, I promise. The first step is going to be identifying the given side lanes. So always look at your image, see if you notice any patterns. The next thing is going to be identifying the scale factor. Usually if it's asking you to pick which drawing is the right scale drawing, it's going to give you a scale factor already. So here you should probably have a scale factor given to you. The next thing you want to do is use that scale factor and multiply it to the other side lengths to see what new side lengths you should have, like what we were doing in the examples before this. And then you want to pick the image that has those lengths. So here I have this triangle here. I have 3 numbers on my triangle. I have a 7, I have a 5, and I have a 3. This is my original image. I want to know what the new side lengths will be if I have a scale factor of 2. Okay, so if I look at step 3 right here, it tells me to multiply the scale factor by the given side lengths. So I have a side length 7, side length 5, and a side length 3. All right, 7, 5, and whoops. Sorry, there we go. That looks funny, doesn't it? 7, 5, and 3. And we're back to red. That's fine. Since my scale factor here is 2, I need to multiply it. So I'm going to multiply every single side length. You have to multiply every single length that you are given. If you have a square, you're going to multiply each side by the scale factor. So you multiply 4 total things. If you have like a octagon that has 8 sides, you're going to multiply 8 different things by the scale factor. So here, this would give me 14, this would give me 10, and this would give me 6, which means that my new triangle would have side lengths 14, 10, and 6 down here at the bottom. Okay. So we'll do some examples with this. Here I have a rectangle, so they don't give me the image. It just tells me I have a rectangle that has a width of 5 and a length of 8. So since we're doing geometry, whenever I solve any geometry problem, I always draw a picture. So I'm just going to draw a rectangle. My width is 5, and my length is 8. Okay, remember that in a rectangle, your opposite sides here, this 5 and 5 are parallel, which means they're the same height and length. And my scale factor tells me is 1/2, which means that I need to multiply both the 8 and the 5 by 1/2. So I'm going to have 8 times 1/2 and 5 times 1/2. Remember, you can type this into a calculator. 8 times 1/2 is going to give you 4. 5 times 1/2 is going to give you 2.5, which means that my new rectangle that I'm drawing is going to be 2.5, 2.5, and 4, and 4. So if I look, I have 2.5, 4, 2.5, 4. A looks like a good one. I don't want to pick this one. This one I'm multiplying by 2. I'm not multiplying by 2, I'm multiplying by 1/2. None of these other ones work either because none of the numbers match up. Here I have 4s and 5s, 8s and 2.5s, and then 10s and 16s. So the biggest thing here is to remember to multiply both sides by the scale factor. Multiply both sides by the scale factor. Fifth letter of the quiz code is going to be I as in ice cream. I as in ice cream. So you should have S-N-O-W-I. All right. This problem here, on your checkpoint, there are a few that are like this, so make sure that you're reading it carefully. This problem here, there's a little bit more work because there's an extra step. Okay. It says that a scale drawing of triangle ABC has side lengths of 2 centimeters, 4.8 centimeters, and 5.2 centimeters. The scale drawing was drawn using a scale of 1 centimeter equals 4 inches. Raquel creates a different scale drawing of the original triangle ABC with the scale factor 1/6. What are the side lengths in Raquel's scale drawing? So if I notice, all of my answers here are in inches. However, the given side lengths that I have are all in centimeters, which means that the first thing we need to do is take these centimeters and convert them into inches using this scale that they give us. Okay, so for every 1 centimeter, it's actually 4 inches. So if I were to have 2 centimeters, right, I would have 8 inches, right? So for every 1 centimeter, you have 4 inches. So if I were to add another centimeter, I would have another 4 inches. So if I add these together, 2 centimeters gives me 8 inches, and so on. If I wanted to add another centimeter to this, I would add another 4 inches, which would mean that if I had 3 centimeters, I would have 12 inches. Okay, I'm adding these straight down. That's how I'm getting these. So we're going to do that, and kind of a shortcut way of doing this is just to multiply them all by 4. So let's do that first. Okay, first we have to convert all of our side lengths. So let's do 2 times 4, 4.8 times 4, 5.2 times 4. So this is going to give us 8. I don't know the other two, so I'm going to bring back my calculator to do it for me really quick. 4.8 times 4, and then 5.2 times 4. 20, so 19.2 and 20.8. So this is 19.2 and 20.8 inches. So now that we have all of our side lengths in inches, we're going to go back to that step 3 where we multiply all of our side lengths by our scale factor, which here our scale factor is 1/16. So I'm going to do 8 times 1/16, 19.2 times 1/16, and 20.8 times 1/16. And when I multiply all of these, that's going to give me my new side lengths for Raquel's drawing. So let's bring back my calculator because we have some fractions here. So 8 times 1/16, 19.2 times 1/16. Oh, that's why. I should be 19.2. That not change it. Let me just redo it. 19.2 times 1/16. And then I have 20.8 times 1/16. Alright, so these are my 3 side lengths. So I have 0.5, 1.2, and 1.3. So if I look at my answer choices, A is looking like a good option, right? Because that gives me all of my new side lengths. So for here, for this one, you'd actually want to pick A. So this was 0.5, 1.2, and 1.3. So for this one, you have to be extra careful when you're doing these, okay? Because a lot of the questions will sometimes try and trick you, but you're smarter than that, so don't be fooled, okay? Just make sure you read it carefully. Reread it multiple times. When I was looking at this problem, I myself, to understand what I had to do, read it at least 3 times, okay? And make sure that you're just paying extra attention, because it's kind of like if they give you this information here, this 1 centimeter equals 4 inches, they probably want you to use it, okay? And then I made the connection because I was like, oh, well, these are given to me in centimeters, and all my answers are in inches, so I need to use this to convert from centimeters and go to inches. So it's just the small details like that you want to make sure you really pay attention to. So this is a checkpoint question I wanted to go over because I thought it was it's not tricky, but I wanted to explain how the thought process and how you actually do this. It says that a model of a house is shown below. So this is the model. And the actual house itself is 20 feet tall. Okay. So if the actual house is 20 feet tall, that means the actual house, this is going to be my original, right? The house is the original, which means that this tiny house here is my new scale drawing. So when I think back to how I find my scale factor, I put new over original. And if it tells me that the house is 20 feet tall, right, tall is height, which means I'm looking at this number here to make my scale factor, right, because this is how tall the house is. So my new height is 27.5. My original height is 20. So I'm going to take my scale factor of 27.5 over 20, and let's see if I can simplify it. So I'll clear this out. 27.5 over 20 simplifies to 11 over 8. Okay, oops. So I'm going to take this 11 over 8, and I'm going to multiply it, remember, by my unknown side lengths. This is finding an unknown side length. So 11 over 8 times this 25, because that's the side I know. This, when I multiply these two, it's going to tell me how many feet the actual house is for the width. So I'm going to take the 11 over 8, and I'm going to multiply it by 25. Did I do it wrong? Did I type something in wrong? Let me double check. So over times I think I'm missing a step here. What's happening in my brain? It's a Friday afternoon. Do any of you guys have this happen on Friday afternoons? I'm sorry. Let me pause the recording while I figure this out. Alright, I'm back. I know that wasn't a lot for you. I figured it out. So, I confused the original and the new, which means that the 20 feet should be your new. Think about like whenever they are constructing houses, they probably draw a scale of it first before they just build the house, right? So that means that this 20 feet tall, that's going to be the new height of your house, right? And this over here is the original scale drawing. So that was my mistake, I apologize. But if you kind of think about it, it does make sense. Even like when you're building an airplane, you usually make a small model of it first, which would be your original, which would make this 27.5 go on bottom, if I can do it, 27.5 on bottom and 20 on top, which then just switches our numbers, which would give us 11, nope, 8 over 11. So if I swap this and do 8 over 11 times 25, you get 18.18, which is D. So that was that one. I apologize for the confusion. I got them switched up in my brain. I'm sorry. Sixth letter of the quiz code is going to be N as in natural. N as in natural. Alright, so this question here is a quiz question. It will be on your quiz. It will be live on Tuesday the 26th at 10:30. So after the live session. It says that a scale drawing of a rectangular wall has dimensions of 47.5 inches by 2.5 inches. The length of the shorter side of the wall is actually 36 inches. What is the area of the actual wall? So I wanted to go over this one for a few reasons, and the main reason being there's a lot of things happening in this problem. So what I would always suggest is to draw a picture, because doing this without a picture for me it's hard. I like to see what I'm doing. So it's a rectangular wall, right? So I'm going to draw a small rectangle, and I'm also going to draw a bigger rectangle. It tells me that the wall has dimensions 4.75 by 2.5. Okay. And it says that the length of the shorter side of the wall is actually 36 inches. So the shorter side of the wall for me was up top, which means the shorter side for me again is also going to be up top. And I want to know what the area of the actual wall is. So I first need to figure out what x is over here and then multiply these two together. So again, let's find our scale factor. So original 2.5, new is 36. So my original 2.5 goes on bottom, 36 is going to go on top. And let's simplify this. So I'd have 36 over 2.5. Gives me 14.4 or 72 over 5. Neither of those are really good, so we'll just leave it at 36.25. And then remember to figure out what x is. I need to take my scale factor and multiply it by the known side, which is this 4.75. Right? I want to know how tall this side is, which means I need to use this side number to tell me. So I'm going to take my scale factor of 36 over 2.5 and multiply it by 4.75. So then bring back our calculator, and this would be multiplied to 4.75, which tells me that it is 68.4. So 68.4. So this x over here is going to be 68.4. Now the last step here is we want to know the area of the wall, right? And to find the area of a rectangle, you do length times width. So I'm going to do this 36 times 68.4. So 68.4 times 36 gives us 2,462.4. So that means that the area here is 2,462.4 inches squared. So the actual area is 2,462.4 inches squared. You can just type in the number, it should be fine. So I want to recap everything that happened here. The first thing, I drew a picture, right? I knew that one side was 4.75 and the other side was 2.5. So I drew a picture here. My next clue said that the shorter side of the wall is 36 inches. So since this 2.5 is smaller, meaning that this side of my rectangle is shorter, that this top side also has to be my shorter side, because 2.5 is on the top, which means 36 also has to be on the top. The next thing I did was I used these two sides here, 2.5 and 36, to find my scale factor. Okay. Once I found my scale factor, I wanted to know what x was, which is on this tall side. So I needed to use my known number on the same tall side and multiply it by my scale factor. Okay. Once I had both of those multiplied together, I got this 68.4. Then I took this 68.4 and multiplied it by 36. I multiplied these two to get my area, which was 24.62. Okay. So don't forget, this is a recording. If you want to replay this and have me re-explain it again, you have that option, which is actually kind of cool. The last letter of the quiz code this week is going to be G as in glass. It is snowing. Not like it's snowing now, but the quiz code is snowing. So hopefully if you read through these, you can do all of those. The scale factor stuff is not easy, so if you want some extra help or have questions, please feel free to ask me. I'd be happy to work with you one-on-one. Other than that, make sure that you take the week 16 quiz, which will again be live on November 26th at 10:30 a.m. The quiz this week is due on Wednesday because we will not be here on Thursday or Friday, so it's actually due Wednesday this week, so make sure you do take it. And again, if you have other questions, please let me know. But other than that, I hope you have a wonderful rest of your day, and I will talk to you later. Bye.